Welcome to DriverDTrains. Thanks for stopping by. I'm your host, Driver D. Our conductor and brakeman, Scratchy C, went off to have a word with the yard master. In my last video, designing the DCC, I showed you how I designed the small 1 foot by 6 foot HO scale switching puzzle layout I built on a shelf. That is my version of John Allen's famous Timesaver layout. If you haven't already seen that video, be sure to check it out. In this video, I'll show you how I assembled the basic hardware for a DCC-EX command station to control my trains using an Arduino Mega microcontroller. In the next video, I'll show you how to download and install the free DCC-EX software and add some upgrades to the system. I'll also show you how I installed the Y-Throttle app on my phone and tablet to run my trains and control the layout. In later videos, I will show you how I set up JMRI to program my locomotives and how I use JMRI throttles to help me run my locomotives. And I will introduce you to my custom-designed DCC switching puzzle app running in Microsoft Excel, which I use to generate the switching puzzles and keep track of all the operating sessions. After that, we'll look at some upgrades to the DCC locomotives, the command station, new throttle options, and the eventual painting and scenicking of the layout. And we'll run some switching puzzle operating sessions on the DCC. As you can tell, there are a ton of great videos coming down the track, so be sure to subscribe to the channel, like the videos, and hit the notification bell so you won't miss any of the next installments. Also, be sure to check this video's description for links to the various websites and products I mention here. Now let's fire up the engine and get this train rolling. DCC for the DCC. I designed the DCC so that I could run my DCC sound-equipped locomotives on a small switching layout. DCC, or Digital Command Control, is a National Model Railroad Association standard for electronically operating your locomotives and layout using a digital or computerized signal sent with the track power. Although I already have a DCC system buried somewhere in the back of a closet, for the DCC I wanted something more portable and the ability to use Wi-Fi throttles like my phone and tablet to control my locomotives. So I decided to assemble a DCC-EX command station. DCC-EX is an open-source DCC software package that runs on readily available Arduino-based microcontrollers, which are popular in the maker and tinkerer communities. Originally released in 2020, DCC-EX is an upgraded version of an older open-source program called DCC++, which was originally released in 2015 by a developer named Greg Berman. The DCC-EX developers took the base concept from DCC++, rewrote the software to make it faster and more expandable, and added many new features and enhancements. Originally called DCC++EX, short for DCC++ Extended, in August 2022, the developers shortened the name to DCC-EX to simplify things and reduce confusion. So if you see a reference to DCC++, that is the older 2015 program, but DCC++EX and DCC-EX are one and the same and what I chose for the DCC. If you're interested in using DCC-EX on your model railroad or in learning more about DCC-EX, be sure to visit their website. I'll include a link in this video's description. As I mentioned, DCC-EX runs on an Arduino-based microcontroller, or a compatible clone. An Arduino is a single-board microcontroller specifically designed for interacting with and controlling both digital and analog inputs and outputs, such as sensors and motors. The base Arduino board can be expanded with additional task-specific expansion boards called shields that stack on top of it. For the model railroader, the most important of these is the motor shield, which is designed to drive inductive loads such as, well, motors. The motor shield has two separate, independently controlled outputs, which means that we can use one Arduino with a motor shield to control both our main track, which can run multiple locomotives, as well as a separate programming track. Once I had settled on DCC-EX for the D-Saver and was confident that my track plan would work, I needed to order the necessary parts and assemble the Arduino-based command station. You can find a list of all the necessary parts and various options on the DCC-EX website. I'll also include the list and links to all the parts in this video's description. In this video, which is part 1 in a series, we'll start with the basic command station, the bare minimum you will need to run your trains. I'll walk you through everything you need and how to assemble it step by step. In the next video, part 2 in this series, I'll show you how to download and install the DCC-EX software that you will also need to run your trains. Then, after we test that to make sure everything is working, we'll circle back to add a Wi-Fi shield and an LCD display to the command station and upgrade the software. So without further ado, assembling a basic DCC-EX command station. Step 1. Get an Arduino Mega microcontroller or compatible clone. The first item we will need is the Arduino microcontroller or a compatible clone. The Arduino comes in a variety of physical sizes, which have different numbers of input and output ports, as well as different amounts of memory. I highly recommend that you start with the Mega Rev 3, which is currently the largest in physical size and has the most features and memory. It also supports all of DCC-EX's features, whereas the smaller boards don't. The other point I want to make is that you do not have to buy an Arduino branded board. A number of different manufacturers make Arduino-compatible clones. Elegoo is one of the better-known off-brands and endorsed by DCC-EX. I found the Elegoo Mega R3 available on Amazon in mid-2023 for $21. It comes with a short USB cable to connect to your computer for programming and power. But if you have a longer, old USB printer cable, you might want to use that instead for convenience. Note that you do not need to buy a separate power supply for the Arduino controller. It will get all the power it needs from the USB, either plugged into your computer or plugged into a USB wall adapter, like the kind you would use to charge your phone. If you're like me, you've got a drawer full of those. You can even run the Arduino from the USB port on a battery pack. If for some reason you really want to buy an AC-DC power adapter for the Arduino, you want one with 9 volts DC output and a 5.5mm by 2.1mm center positive barrel connector. This one is available on Amazon for $10. If you don't already have a spare USB cable and adapter, you might decide to try this instead. Just remember that you will still need to plug the Arduino into your computer once in a while to install and upgrade the DCC-EX software. Step 2. Get an Arduino motor shield or compatible clone. The second item you will need is an Arduino Rev 3 motor shield or a compatible clone. These are also known as L298 dual full bridge drivers, and you want one that is designed to plug into the Arduino Uno or Mega. Arduino motor shields typically have the smaller footprint of the Uno, but are designed to also fit perfectly and work with the Mega. I found this Kabuk off-brand one on Amazon for $17. You can say that forwards or backwards, although the board I received is actually branded as a Deke Robot, which is one of the motor boards recommended by DCC-EX. Thank you to whomever left the review in November of 2022 to let me know that it works perfectly with DCC-EX. There is one other option that you might consider. In May 2023, DCC-EX announced the release of their own open-source EX motor shield, custom designed for DCC-EX, with an initial batch for sale made by their Austrian manufacturing partner Semify. The EX motor shield offers a number of advantages and features not available elsewhere, including dual 5-amp outputs compared to less than 2 amps for a typical motor shield, hardware over current protection, and the ability to safely power the Arduino controller from the motor shield. The EX motor shield is a new product, and availability is currently somewhat limited. I ordered mine directly from the manufacturer in Austria. The price of the EX motor shield is also about double that of a generic board from Amazon. I paid $40 plus $23 for ground shipping from Austria, and the motor shield took several weeks to arrive. I'll share more details about my experiences with the EX motor shield in a future video. Step 3. Assemble the Arduino controller and motor shield. It's almost time to assemble the Arduino controller and motor shield. However, before we can do that, we need to make a slight modification to the motor shield so that we don't fry the controller's circuits. The standard Arduino motor shield is designed to send power to the controller board so that when you use a motor shield, you don't need 2 separate power supplies. However, the voltage and current we need to run model trains off the motor board could easily fry the controller, so we need to prevent that from happening. By the way, this assumes that we are using the standard Arduino-style motor shield or a comparable clone. The EX motor shield is specially designed for running model train layouts and provides a safe, controlled voltage and current to the Arduino controller, so we don't need to perform this step. However, for the standard Arduino-style motor shield, we need to make a small modification by cutting the small jumper trace in the middle of the voltage in pad on the back of the shield board. It's the one labeled VIN, and we can do this with a small X-Acto knife, or even a box cutter in a pinch, as I did here. Once we cut the trace, we need to check with a voltmeter to make sure that no current is flowing across the pad. Then it's simply a matter of carefully inserting the pins of the motor shield into the correct header sockets on the controller board. Check the labels on both boards to make sure you are lining up the pins correctly. Then gently start lining up the pins on one side from one end to the other, but don't press them in yet. Sight down the length of the board to make sure that none of the pins are out of alignment. Then do the same on the other side. The pins on my motor shield were bent during shipping, so I had to help them into the sockets with my fingers. Once all of the pins are lined up on both sides, gently start pressing them into the sockets. Go back and forth from side to side to make sure all the pins are firmly seated in the sockets. We have now assembled a basic DCC-EX command station. The only other thing we need to do is add power, and that's all there is to it. After that, everything else just adds additional features. Step 4. Wire up the track and get a power supply to run our trains. Now that we have assembled our basic DCC-EX command station, we need to hook it up to the track and provide power for the trains. The standard Arduino motor board has 3 pairs of screw terminals, 1 pair for power in, and 2 pairs, an A pair and a B pair, for 2 independently controlled motor outputs. By default, the A outputs will power the main track, while the B outputs will power our programming track. We will need 3 pairs of wires to power our DCC-EX command station and connect it to the main track and programming track. To make the connections easier, I recommend using some of these screw terminal barrel connectors, male and female, in the 5.5mm by 2.1mm size. Let's take a moment to talk about wire. I originally tried to use stranded speaker wire to hook up the command station to the D-Saver, but ran into a number of problems. The screw-type terminals on the Arduino motor shield and the barrel connectors don't work well with stranded wire, as the screw clamps spread the wire strands, which eventually causes them to come loose and even break. So I switched to solid core wire. This works much better with the screw terminals on the Arduino and the barrel connectors, although the wire is stiffer, making it a little harder to move the command station around. It's also important to be aware that the overall diameter of solid core wire and stranded wire of the same wire gauge is different. I originally started with 22 gauge stranded speaker wire, but when I switched to solid core, I used 18 gauge wire, which was the same overall diameter. When I add additional power drops to the D-Saver in the future, I will use 22 gauge solid core wire, which is much thinner than what I used here, but still more than enough for such a small layout. Once I had the wire sorted out, I prepared 3 connectors, one for the power supply and one each for the main and programming tracks. I made these all slightly different lengths so I could keep track of which was which, with male connectors for the track leads and a female connector for the power lead. I soldered 2 pairs of track feeder wires onto 2 sets of rail joiners and attached female barrel plugs at the other ends to plug into the male plugs I had installed on the leads coming from the motor shield. With this wiring in place, the DCC-EX command station was now hooked up to the layout and the programming track and ready for power to run the trains. To power our train layout, we will also need a power supply to plug into the motor shield. The exact nature of the power supply you will need for your layout depends on what scale you model. For HO scale, DCC-EX recommends a 12-volt, 5-amp power supply, such as this one I purchased from Amazon, which is currently $13. I actually paid $18 for it when I purchased it several months ago, so inflation must be cooling off. The 12-volt power supply works great for my relatively modern HO scale Athearn Genesis units, but doesn't work as well for some of my older locomotives. Ideally, for HO scale, I would prefer to have a 16 to 18-volt DC power supply running 4 to 5 amps. This is comparable to the MRC Prodigy I have in the closet. However, I had a hard time finding a suitable power supply in that voltage and amperage range during my initial searches. Then, some months later, I found this Black Star guitar amplifier. The 40-watt version of this amp uses a 16-volt, 3.5 amp power supply and takes a barrel plug almost the same size as the plug I had. I found several options on Amazon for a replacement power supply for this amp, including some that are rated at between 4 and 5 amps. I purchased this one for $17, although what I received looks different from this photo. It looks more like this one. In fact, it looks almost identical to the 12-volt one I bought. And it works great for some of my older locomotives, which run much better on 16 volts. Be sure to consider the needs of your own locomotives before choosing a power supply. It's better to be safe than sorry, so do your homework and consider trying a few options, starting first with a lower voltage power supply like I did. What's next? Installing DCC-EX. We now have all the hardware we need to run our trains, and it's time to download and install the DCC-EX software. Then, after we install and test the software and try running our trains, we'll add a Wi-Fi shield to the command station and install and program a digital LCD display. However, this video is getting long, so we'll take all that up in the next one. So stay tuned so you won't miss it. That wraps up this part of assembling a DCC-EX command station. Thanks for watching. Well, Scratchy, did you get any satisfaction from the Yardmaster? You did? Great! Then let's grab our engine and find our train. Until next time, all aboard!